So, in today's lecture, we're gonna introduce a new modeling algorithm called decision trees. Decision trees is one of the most used algorithm in the business domain. So I should remind you what I mentioned at the beginning of the semester, that data mining in general used to be taught only in scientific disciplines such as computer science or in biochemistry or in biostatistic domains. It's more like related to some type of scientific problems that you want to mine. However, because of the wealth of information now we have, especially with the internet and the huge amount of data related to business, data mining started to invade the business domain and became very popular, specifically with the predictive analytics concept that it can cover. So one of those concepts that are really used and adopted in the business domain is decision trees. And as usual, we're gonna start with a business case scenario to introduce the problem, and then after that, we're gonna talk about how the decision trees model works and how you can interpret the results, and accordingly, at the end, we will compare it with the other models we covered so far in the semester. So here's our, our fake case study. So assume the following: Richard, who works for a large online retail, his company is launching a new next generation, let's say, of iPad. That's why you see the image of iPad on those slides, or maybe if you're not a Mac user, you might consider a Samsung tablet, etc. So let us call it e-reader. So his company is trying to launch next generation, the most recent version of the e-reader, and he really wants to maximize the effectiveness of his marketing to customers. So he also have many customers historically that did some purchases from the company website, and those purchases related to his previous generation of digital readers, and also more information about what they have been purchasing over time. So let me open the first data set that you will be using in this case study. So this is our customers here. So he has information about the ID of those customers, their gender, their age, marital status, their website activities, and that's, we have to investigate what that means. It is a categorical type of information. It has a three category: frequent customer, regular, and seldom. Okay, and we're gonna talk about the meaning of those in a second. Also, he has information about, so each row is each one customer, so he knows his ID, his gender, his age, marital status, how often he visits the website, if he browsed. It doesn't have to be bought, he just browsed electronics devices on the website over the last 12 months. Did he buy that person the electronic devices over the last 12 months? But digital media, could be maybe a new book on to be installed on his e-reader. So also we have information about the customer, if he bought or maybe music songs, okay, from iTunes, related through his company. Did he buy digital books? Actually, we have specified one column for that. So here, I would say, so the media here maybe will be more maybe the audiobook version of the book. Let's put it in this way. Okay, also what kind of payment method that person used when he purchased over the internet, and is he has somehow categorized that person as late majority, and we're going to talk about how that happened. So he has historical information about customers in the past, and his goal, as usual, is to create a model from this data to be able to predict what kind of customer, this is new person that visiting his website, but he did not historically purchase an e-reader. He purchased some type of other devices. That person, he purchased maybe digital books, but the actual e-reader iPad or the Samsung one, he didn't purchase it from that specific company. Okay, so from here, as you can see, the missing attribute, we don't know what kind of adapter this person is gonna be. And the goal is, as we said before, to model historical information, and that will be our label, and accordingly we can predict what kind of customer each one of those customers gonna be considered based on the decision tree model. And accordingly, what he's gonna do, he's gonna try to have a marketing campaign that is different based on the type of behavior that customer is considered. So if the person is early adopter, he knows he's gonna adopt very soon, so maybe he will not send him a discount. He will send an email introducing the new e-reader, the next generation of the e-reader, but will not send at all a discount. However, for those who are late majority, he knows those gonna adopt eventually. He doesn't want them to buy the iPad, for example, from Apple Store, so he might send them a promotion, let's say 10% if you buy it from our company, so that would be tempting to change their status from late majority to early adopters, for example. So that's the goal of this study. The goal of this study is to be able to predict the behavior of the buyers, and accordingly you create your marketing campaign based on that categorization that you found that customers belong to. Okay, so what kind of customers really he has, we're gonna look at those in more details, but more what he's asking, he wants somehow to, of course the goal is to sell as much as possible, more products to customers, so that's his goal. And through the marketing campaign he can really categorize those type of profiled customers differently, and he can target them differently as well. Now let us go back to this chart over here. So let me introduce a new concept, what is a very old concept actually, but is related to this case study, what is called the Everett-Rogers theory of adoption of a new innovations. It's very old theory, actually in 1960s, first time Rogers theory was introduced in the sociology domain. Okay, so Richard wants to be able to predict the timing of buying behavior, so that's important. He also wants to understand how his customers' behavior on his company's website indicate the timing of their purchase of a new reader, okay, e-reader. So based on the Everett-Rogers theory, which is also called the diffusion theories, in general, the theory tells you that adoption of new technology or innovations tend to follow this type of the S shape. Okay, and what it means that any innovation starts by attracting a small amount of customers, then it grows dramatically and then stabilize over time. Now, if you look at the not the cumulative number of adopters, at the normal distribution of, in general, any adoption, it follows a normal distribution. And if you look at this blue bell shape curve, you can consider those people in this section here are the early adopters, the innovator, the one adopt immediately the technology, and the one here in the long tail, those are the one that usually are called the laggards, like they stay to the last minute to adopt the technology. But as you can see, somehow the bell shape is a flat bell shape. It's not like sharp bell shape. So 70 to 80% of the mass population of buying fall in that area. So we have people who adopt technology very quickly, some would adopt very late, and but majority will fall in the middle. So this is what we call the tails, the end tails. So this is the beginning tail and the end tail. So the end tail, what is called the late majority of people that for example, CDs, DVD players. In the past, people, some of them will go buy it immediately, and then others will follow after time. The same with cell phone technology. At the beginning, very small amount of people bought the iPhones. Then, after a while, most of the people have iPhones. Not all of them, but most of the people adopted the technology. Okay, that's a typical behavior, what is called the diffusion of technological innovation, and it's really known in the sociology, and the marketing domain uses this to predict customers' behavior. So what he hopes, Richard, is by watching the customer activities on his company website, he wants to be able to anticipate approximately when each person will be most likely to buy this e-reader, the new e-reader. And he really believed that predictive modeling can help him reach that goal, and somehow he would like to know the time that each buyer's category gonna be categorized in, and accordingly his marketing to those customers will coincide with their likelihood of buying. So that's the whole idea. So he engaged us. Okay, so he's asking us to help us, ask us to help him to discover this type of timing behavior, to be able to target his marketing to people most ready to respond to advertisement and promotion. Okay, that's his main goal. Now, what else? Let me talk a little bit about the data itself. So we looked at the Excel file and we saw what kind of data we have here, but let me also show you the data dictionary, because that would be also helpful for you. So let me go back. Okay, better to download it. Okay, so in the handouts you can see the output you can see the handouts. This is the data dictionary, the Excel file that I showed you, and as always mentioned, before starting any case study, you really need to look at the data in details understanding what type of attributes you have. Is your variables, is the variable or the attribute or the dependent independent variable is categorical? Is it continuous? Is it discrete? Is it text, maybe like if it's Twitter data? So what we have here, the user ID, which is a numerical type, and we're going to introduce something new in this case. Like when you have user ID, rule of thumb is not to have the user ID interfere with your model. So you have to tell the application you're using that don't include that variable within my model. So you have to tell RapidMiner it is a user ID, so this way it knows not to include it. So we have the gender, which is categorical, male and female, and it's a nominal. So there's no order here. Age, it's a numeric number. Okay. Marital status, here we have married and single. Okay, and what website activities? These three different categories: seldom, regular, and frequent. This is how he categorized it based on the time that they served over the internet. And we mentioned those. So the rest of those attributes are yes, no type, which means yes, he purchased electronic or he didn't. Okay, so this is a categorical or binomial two category type of information. The payment method, we have 4 different categories, so also it's categorical with 4 different type of category. The e-reader adapters or adoption, we have let's go back here to show you. We have these types of categories applied to the e-reader adapter. Either they are innovators, that mean immediately they purchased the new last time when the next generation of the e-reader appeared, immediately they bought it in a small period of time, and we're going to talk about those period of times in a second. The second one, early adopter, which is also right after the innovators, and the early majority, and finally late majority. Those are the laggers. Okay, and so here is more details about each one of those categories to understand it better. So those who adopted within a week, so the first week the e-reader was announced, is available in the market, the innovators, people purchased it. So those are the people who purchased during the first week of new products appeared in the market, or the e-reader appeared in the market. The others who started after the first week, so starting from the second to the third week, are called early adopters. Okay, after that, who started from the after the 3 weeks, and for during the first 2 months, so between 4th week and 2 months, are called early majority. And finally, whoever purchased after 2 months are called late majority. And again, we don't have control over this type of category. This is what he did in the past with his customers, and accordingly he categorized this attribute with these 4 different categories. Okay, so something to note with decision tree, that people like to use decision tree as even as a test platform. Like whenever you have data, just try first with decision tree to create a model, then move to another complicated model, for 2 reasons. One, decision trees run even if you have missing values. As you remember, when we covered the linear regression modeling, we said that you cannot even generate any model if you have, let's say you have millions of records and one record has no information in it. A linear regression cannot be created if you have a missing value. However, decision trees, if you have missing values, it will work and will list that missing value in one of those branches. Very good. What else? Number two, if you have some type of um, ranges different in the training from the scoring, it doesn't matter. It's gonna create a model from the training and it's gonna score this new data on the model. So that's why is favored by a lot of applications to use decision trees, and also it's known to be a very fast method to produce the results. So that's why it's used over the internet in any type of prediction that you work on the internet. So for example, a lot of the online analytical applications such as IBM Watson, it uses decision tree as a predictor algorithm behind the scene. Okay. So the typical scenario, we're gonna bring the training data, and then from the training data we're gonna set the role, that this is the role is the e-reader adoption will be our label, and then we're gonna create a decision tree, and we start our work from there to read what the decision tree gonna produce. And as you can see, it's called decision tree because technically that's the output. It's gonna look like a tree, and you will have the root, you will have the branches, and then you have the leaves at the end of each of those branches. Okay, so let us go back and start somehow understanding what's going on in this part of the analysis. So we created a decision tree. There are parameters, like we noticed before. Every model has its own parameters. However, in this model we're gonna a little bit tweak those parameters and try to enhance our understanding of how you can tune your model and the capability of tuning in RapidMiner. So when you start your first decision tree, you have some predefined setting. So the criteria that the cut's gonna happen on, which means the algorithm is gonna use one specific criteria called the gain ratio, and we're gonna talk about it when we go into the RapidMiner application. We're gonna see some different criteria, but simply to explain to you what's happening here, we're gonna create a decision tree model based on the historical data of the customers Richard has. Those are the one who last year he collected and they bought next generation, so he knows a lot about them. And in this case we have maximum depth 5, which means if I have a tree, the maximum branches that tree can have is 5, and you can control this. You can make it bigger or smaller. Now the checked box here, apply pruning. Sometimes if you don't apply pruning, the tree is gonna be so big even without really additional information spread around. So the pruning, it means like when you reach the level depths of 5 and you see this is the best model, just to prune any type of information behind the 5. Okay, and the confidence level, now we're gonna start learning about how to evaluate a model. In this case, the evaluation, the confidence level here is 25%, and we're gonna talk about it. Also, the apply pre-pruning is selected, so even from the beginning of the model is gonna start with some type of recursive application at the beginning, and to pre-prune some of the output that is really not doesn't have very high confidence level in it, so will be pre-pruned even before creating the tree. Okay, the minimum leaf size, which means the output that is allowed to be as a leaf, is 2. In our case we have the leaves should be according to what your output is. So we have the e-reader has 4 different categories. So our leaves level, it is selected 2, however it's gonna generate 4. Okay, but it's saying in those branches I don't want you just to generate one. Minimum, you have to put 2 leaves outside. Okay, and of course you can readjust those the way you want it until you find that the decision tree is the most appealing, or the most understandable, or the most revealing of information to your business case scenario, and those are changeable over time based on the data you are handling. Okay, so this is what RapidMiner produced after we run the training data set. Okay, and I'm gonna try to explain to you what's going on over here. So we can see that what is referred to as a nodes or leaves, those are the colored ones. So those are the leaves of the tree, the last stage, or the last branch of any tree. Okay, and those are the leaves are the one that you gonna understand what's happening to your customers in those leaves. Okay, now since we have a couple of data attributes, let me go back here. So this is how you have to imagine it. So this is gonna be the output of the decision tree. We told decision tree that this is our label, so this is our dependent variable, this is our y. Okay, and all the rest here are the axes. Okay, those are the axes. We're gonna exclude the user ID. It's not gonna be one of the axes from the beginning, but our axes are gender, age, marital status, website activities, browsed electronic in 12 months, 12 months here bought, browsed or bought media 18 months, bought digital book, and payment method. So we have those 9 attributes. They're gonna contribute to create a decision tree. And the way it works, since we decided to use the gain ratio as our criteria, our algorithms, the gain ratio criteria is gonna be evaluated for each one of those attributes, and then the one that produces the most variation in the tree is the one's gonna be picked up as the root of your tree. What that mean? Okay, if you remember back from your stat, and when you create a linear regression model, you might have many different independent variables to create your dependent variables. So why you are trying to create this formula in which only include the independent variables that contribute to the dependent variable, to the y. This is similar with decision tree. You're gonna find which one of those attributes in your data, which one of those independent variables that are the most important to decide the value of your y. Not only that, in decision trees you rank them as well. So if you know that only the gender and age and let's say both electronics in 12 months, only those 4 variables are significantly important, their p-value is significant to your y, to your e-reader in your linear regression, so you're going to include them in the linear regression formula. However, in decision tree, assume yes, those are the same 4 variables that are the most important. However, is going to rank which one among those 4 is the most important. So if the and the value here that decides which one is the most important is not the p-value in linear regression, but rather is the gain ratio criteria that being measured based on each one of them. So assume that the best one that has the most important one among all those attributes was the broad electronic 12 months. This is gonna become the root of the tree, the first branch of the tree. Okay, so let us go back now. So according to what you see here, it wasn't the one I just showed you, but rather the website activity. Okay, the website activity. The website activity, this variable number 5, the one that has seldom, regular, and frequent. This is the variable or the attribute that the gain ratio was the most important, had the best value among all the rest for building a decision tree. So imagine like you build, okay, let's make it simpler even. You built 9 different trees. Each one has different root. The first tree has a root of gender, like the first branch called gender. The second tree called start with age and continue down. The third start with marital status, continue down. The fourth will start with website activities and continue with the decision tree down, etc. until the payment method. So you have those 9 different decision trees. Each one, the starting point of them is one of those. You compare those, is what does Rapid Miner behind the scenes. It compares all those 9 trees against each other's and look at the best one among all of them. Which one that really has the highest variability among the attributes to be considered the head of the tree or the root of the tree or the beginning of the tree. So in our case, in this data, the website activity apparently had the highest number of gain ratio criteria number that accordingly the tree is going to start with. Now the tree started with website activities, and then the value that it takes is frequent, regular, and seldom. So each one of those branches is going to tell a different story, and each one of those branches will have part of the data of those customers. Like this is maybe customer 1 in the Excel file. Okay, let's go back here. Where's our Excel? Customer 1 that has his late majority. Okay, what type of web activity he had. He's a seldom, so let's track that person. Okay, that make it easy. So that person, okay, is a seldom, so it's gonna drop in that area here. Okay, did he buy digital books? Let's see what it says here. Bought digital books. Bought digital books? No, he didn't buy digital books. Okay, so he's gonna adapt in that branch. No. Age. What's his age, that person? His age is 61. So is it bigger or smaller? Is bigger. So it's gonna end up in that branch over here. And that customer, his node is this one. This leaf is his category, and we're going to talk about the colors. This leaf is called late majority, and you look here, he is late majority. But late majority, not only, we have other type like early majority is this red color here. So this leaf has some customers that are early majority and some customers late majority, and it has some customers that are innovators, the green one. However, most of the customers are the blue type, which are the late majority, and that's why this leaf will get the value late majority, because maybe 80% of those customers ended up in this leaf are late majority. Okay, so this is how you look at the data. So let us just some explanation here. If the person's website activities is frequent, okay, it's another branch. If it's frequent or regular, okay, or regular, so I'm going into those 2 branches, we see that they are more likely to be innovator or early adopter. Okay, so let's see why. So because this branch, as you can see here, ended in early adopter, and here ended up early adopters and innovators. Okay, so that's some summary of the business rules, and we're going to talk more about these in details. However, if they are seldom, okay, this branch over here, and I'm going to show you also from where you can get those business rules. if they are seldom use the website, and whether or not they bought digital books, it didn't matter really that much this, but they become the next best predictor for the adoption categories. Okay, what else? Age, another predictive attribute. So who is those who are seldom, another business rule, seldom, and to use a company, and then they have never bought, so never bought a digital book. However, they were older than 25 and a half, so this one, they ended up as late majority. Okay, and those who were younger ended up early majority. So now he can compare customer's age, and based on that he's gonna send different promotion accordingly. So this is another more deep understanding of how you read the decision tree branches. Web site activity, if it's regular, this is a business rule, and if the age is, I'm continuing, is the age is, because it's getting smaller, younger than 62 and a half, in that category unfortunately we have a lot of variation. So look at this node has 6 late majority, 54 innovators, okay, but 75 early adopter. That's why it's called early adopters, because it had the most customers in that node were early adopters. Okay, so it went the type of so as you can see, there's some uncertainty in really deciding with the decision tree which one is really, are you going to consider this early adopter? Innovator is not far away from it, so maybe you will need some other type of model to make a better decision. Who knows? Or maybe when you start evaluating, you will gonna translate this into what is called the confidence percentage. Okay, so we are going back, and what we did in the past, we are doing exactly the same here. We are bringing the scoring data. We set the role here for the scoring data. I made some changes here. I will have to remember what I did, so we'll talk about it. And then we did apply model, and accordingly we were able to predict those customers that are new and we don't know that what type of category they belong to, but the model gonna help us to predict them. And accordingly we're gonna have the following output. For those customers, the model decided that, for example, this specific customer is late majority, and the beauty of the decision tree is telling you how confident it is in each one of those different categories. So the model saying I picked this customer to be late majority based on the decision tree, and I am 75% confident that that should be the category of that customer. So sending promotion for those, you're gonna send only to the late majorities. However, the rest of the percentages are not so big, so I will pick that. This is a good percentage, just good confidence level. Now, whereas if I am looking at the second one that it says early adopters, I will be look at those two numbers. As innovator, 32% confidence, and early adopter 44, not so far away from each other. So I maybe send that person for the innovators and the adopters type of promotion, combine both of them. Now the first one is very nice because, as you can see, 75% it is early majority, and late majority 25%. It's much like three times bigger the confidence of the majority than the late majority. So I will pick that one as early majority. Okay. So you have to remember, and this is what we are saying every modeling technique in data mining, that usually what you do, you go back and forth in your model. The CRISP model is not one cycle. You, every time you come up with a solution, you should go back after the evaluation and deployment. Let's say he did the marketing campaign based on what RapidMiner gave us today and sent those promotions. However, he wasn't happy after 2 months, which is the time that those different categories really distinguish each other, and he wasn't happy with his campaign. So maybe he will decide, Richard, to go back and change a little bit in the data and provide deeper granularity level in the data, such as maybe not only considering the time, but also considering tracking the promotion and what happened after the promotion, and that will be added value to the model. So what else? You might go to the RapidMiner after this stage and change the criteria that decision tree used in your first analysis, the ratio, the gain ratio, and change it to Gini index. In this way, you will get different type of tree, and accordingly you might look at the confidence level and see maybe that tree is really much you like the distribution better than the previous one. So for as example, I give you here, I tracked one specific customer, the customer number 301 in our data, that in the previous decision tree that we used, the gain ratio, the tree told us that that customer is an early majority. So let's see, go back here, see if I took a screenshot. Remember, the 301, he is an early majority and with confidence level 75%. However, when I change the algorithm that the decision tree is going to run on to Gini index, what it gave me actually, this one, that this person is innovator and with percentage about 63%. Okay, so this is the way that you can really distinguish the application of decision tree based on the data on hand. So it varies, and results like this, it makes you feel more comfortable to pick, because really those numbers are small compared to this one, and that almost this is zero. So you're choosing to the innovator type for that customer, and the promotion sent to innovator type will be more adequate maybe. Okay, so it's up to you to decide on that. Now the deployment, and we always talked about, it's a cyclic CRISP model, that the idea is you have a business problem that, in our case, Richard wanted to know what those customers, new customers who are buying stuff from his website but never bought an e-reader in the past, he wanted to know how to categorize them into those 4 different promotion categories. So, and the next step is, this is where you have to ask, okay, so we found the knowledge, how are we gonna use this new knowledge for implementing or deploying the model? So what he can do is, this is what you as a business analyst advise the company you're working for to do based on this decision model that you found. So what you're gonna say, okay, maybe you can segment these customers and begin to process the target marketing that is timely and relevant to each individual customer. So those who are, for example, most likely to purchase immediately, this is what the model predicted to be innovator, can be contacted and encouraged to go ahead and buy as soon as the new product comes out. Okay, you know that they're gonna do it, you just tell them. And you might even want to give them the option to pre-order the new device, because most of the times it really they release an iPhone product and sometimes people are like crazy buying it, and you go to the Apple store and they don't have it because it's out out stock and you want it. So you can tell them we can give you a pre-order status, so if you want it right away, and that would be a kind of saving their place for having the device, the e-reader in this case. Now, second thing you can do, those who are less likely to buy immediately, early majority, might need some persuasion. For example, free digital book. So send them an email with one free digital book or two, and so they can purchase the e-reader, or maybe discount on some digital music on the e-reader. Now, the least likely, the predicted late majority, can be marketed to, in a different way, that you have a tight budget and you really you don't think that they're gonna buy, and most likely those customer, they need some type of incentive, so you might give them discount. Okay, you might give them 10%. Look at your profit and see if that's too risky or it's okay, and you might give them that and appeal them with that. Another thing I added here, maybe because those are the early, the innovator who are gonna buy the first week, you might not do even promotion at all to them because you know that they're gonna buy, so you might not waste even $1 spending on sending them a coupon or anything, So who knows? It's based on the marketing campaign that you are building. So the new marketing campaign can use this information to focus more on increasing website activity level or on connecting general electronics that are for sale on the company website with the e-reader and digital media more specifically. This type of promotion is called cross-categorical promotion that can be further used, so you can target specific gender, you can target specific age range. That's the type of marketing that you see in the market. So let us now start with RapidMiner and do the project. So download the data set as usual from Blackboard. So you have the data set available for you inside the dataset under the unit 7. You have both of them, the training and scoring, and start implementing the case study. Okay, shortly it should be available. And it's a good habit to start reading now about the algorithms used in the decision tree. Okay, so just to get more hands-on of what you're doing. So let us add the data first. I'm gonna go to the course. Okay, this is the training data. Good habit to look at the data, and from the beginning I'm gonna change the user ID to the change role, and in this case this is an ID. This is very important, otherwise RapidMiner will think this is a variable that you want to include in the decision tree model. Gender here is 2 category, so I'm gonna convert it to binomial. Age number is okay. Marital status, married and single. I don't think we have more. Let me make sure from the Excel file. Yes, we don't have more, so that's okay. Yes, this is binomial as well. Website, we have 3 categories, so I will keep it polynomial. And this is the same here, yes, no, so this is binomial. Binomial is not going to affect a lot, but it's good habit to know and observe your data and make sure the models are correct. We have more than category, and the e-reader we have more than one category. Okay, so we're gonna bring this data over here, and this is the data. Good habit to look at the statistics. I know we don't have missing data, but a comment I made in this video that decision trees can handle actually missing data, will work even with a missing data. So we look at the gender distribution is accepted, not half 315 female, 346 male. So age, okay, from 16 to 66, also binomial distribution, activities for 3, and we have a different distribution over here, and the adapter at the end. Okay, so at least we took a look at our data. So this is our training data, and let me bring the second one, which is the new customers. They are not good. They are old customers, but they never purchased e-reader from the company. Okay, again, this is gonna change the role into an ID. This is binomial, and this is binomial as well. Binomial, okay, binomial, and binomial. Okay, next, let's go back to the design, and this is our training data set here. Let's do the same. Let us look at the data. I looked at the training, I didn't look at the scoring. That's wrong. Okay, I didn't look at the scoring. Okay, so let's save the process here first, store process. This is decision tree. And now let's run and just look at the data. Let me close, make sure the old data are closed. Run again. So from here you can see it says scoring, training. Okay, so this is the scoring now, and again, no missing data, and this is what we have over here. We're gonna set role. Okay, and the role here is the label, and the name of that attribute is e-reader adoption. That's our dependent variable, the y in our case. Now we're gonna bring decision tree, and you have multiple, so the one we're gonna use is the regular one, and feel free to use the rest. Okay, this is the decision tree, and as you can see from the right side, as I told you, automatically will have some pre-setting. I will minimize the 20 branches. I don't want it to be a very big tree. I'm gonna convert it to 5, otherwise it will be very difficult to read it. And this is where you spend most of the time if you are a business analyst, to tweak this information to get the best decision tree model that really distributed well. So let me run it, and here is the tree. Let me close this one so you cannot see it. You can drag, as we saw in the notes. This is how you can drag it with your mouse. You can drag the whole tree. If you click any place on the white area, you can drag it left and right as you wish. Okay, Now, what I would like to mention, instead of reading those business rules, the beauty of the software RapidMiner that gives you the business rules. So this is exactly what you interpreted, or I interpreted for you when I was reading the tree. So this is how you can read it. If a customer visited the website frequently, visited the company website frequently, and he is older than 37, and he never bought digital books, he would be considered as early adopter. Okay, that's his category based on this decision tree. Now, if he is okay, this is older than 37. Now, if he is if his activities are regular, so he's a regular visitor, and this is based on what Richard considered frequent and regular and seldom. He didn't give us information specifically. I hope I was looking for to see if there's any details about, but doesn't matter. This is the business case you are given, and you have to follow the categorization he made. Okay, so if that person regularly visited the website and he was older than 65, he's considered early majority. Okay. However, if he was seldom and he never bought a digital book and he was older than 25, he's considered late majority. If he was younger, he's considered early majority. Now, if he bought digital book and he was older than 64, he's considered early majority. And if he was younger than 64 and a half, actually, if he's younger than 36 and a half, he's early majority. If he's between, older than 63, so between, so here where is the division? If he is older than 63, and okay, so he's late majority. Perfect. So this is how you interpret the results. Now we bring the we're gonna bring the apply model, so we can apply this model. I'm gonna disconnect those. This is your model, and this is the data that we don't know what category they belong to as e-reader customers and what is gonna happen. So we're gonna run it, and here's what the model gave us for each customer in this model. If you remember here, those are the customers, the new customers, and we have plenty of them that we don't know what kind of category or promotion to do for them. Send them discount or send them email, we don't know. But now, after using the decision tree model, we can use it to categorize those customers. So for example, that first customer, the RapidMiner based on decision tree model with gain ratio criteria algorithm, it decided that this guy, this fellow here, is early adopter. And how much confident that decision was with decision tree? 44.4% confident. The confidence level. So let us go back and repeat this and keep track what happens to this. So it was early adopter. So let's see if we change the algorithm, what's going to happen. Okay, so let's pick and as you can see, we have many different types, so just Gini index. And if you want to go in details and to look at the formula for each one, as I said before in the help, you can actually go in details and understand each one of them. So the gain ratio is a variant of information gain that adjusts the information gain for each attribute to allow the breadth and uniformity of the attribute values. Okay, and there's a formula for that. So if you are really interested in more knowing what is the gain ratio, okay, let me copy it and just go to the internet, and I do this with a student in computer science. We dig deep and knowing each formula. However, as a business major, tree, you really don't have to go into that much of details about how each one of those works. So there are a lot of slideshow, but I'm gonna go to Wikipedia just to give you some little information about it. So this is how the gain calculation is calculated. So technically, when you have the set of training examples, so the function below denotes the set of possible values of the attribute to fall into specific category. So again, it's how much more gain you get if you base your root of that tree on, as we said, website activities or the others. So let us try the Gini index and see what's gonna happen. I kept it 5 here. Let us run. Technically it didn't bring almost anything, so let us go back and tweak it a little bit. So there's something here. I am applying the pre-pruning, and that's what you do usually, just try and error. In general, that's what we do. Now we have a tree, so let me bring here, and again it picked the website activities as well as your root of the tree. However, the business rules now a little bit vary. If you remember, we didn't have those ages. We had totally different domains, and the website was the first, and then as you can see here, the both digital books is included. Okay, in more details over here. So let us see the examples now. So make sure that this is the example of the new criteria. So let me run it. Okay, and here's the examples. So the first guy changed. Now he's innovator. And how much the confidence of him being an innovator, 50, almost 53%. I would feel more comfortable picking this tree than the other for that specific customer. However, in general, you don't base your decision of picking which method of criteria cutting based on one customer. You pick it based on all the customers or the total variation of the output, and we're going to learn those in model evaluations. So in the time being, that's all we have to cover about the decision trees. They are cool because they are easy to interpret as a decision, business decisions that you can make, and it's intuitive, and it's really nice to be used as a first model before digging deep into more complicated models. Okay, that's for this video, and you will have an assignment associated with decision tree.